Hello students, today we will be learning about mountains, plateaus and plains. After the completion of this lesson, you will be able to understand about the mountains, plateaus and plains, understand about the formation of mountains, plateaus and plains. Introduction. Earth's terrestrial surface displays a variety of natural landforms including mountains, plateaus and plains. Mountains arise through different geological processes resulting in three main groups: fold mountains, block mountains and volcanic mountains. Plateaus represent elevated land masses with notably flat tops. Plains, differing significantly, are vast stretches of flat or gently sloping terrain situated at low altitudes. Let's understand about the shaping of Earth's surface, landforms and their origins. Our planet's diverse landscapes from towering peaks to sweeping plains are the dynamic result of continuous geological activity driven by two fundamental sets of forces: internal and external processes. These forces operate over vast timescales, constantly sculpting and reshaping the Earth's surface. Internal geological processes. These powerful forces originate deep within the Earth's interior, primarily fueled by the immense heat generated from the planet's formation and radioactive decay. Mechanism. This internal energy drives the slow convection currents within the semi-fluid mantle, which in turn move the rigid tectonic plates forming the Earth's crust. The interactions at plate boundaries, the collision, separation, sliding, are the primary engines of internal processes. Effects. These processes fundamentally alter the crust itself. They cause significant vertical and horizontal movements, leading to, firstly, uplift. The rising of large sections of crust forming features like mountain ranges, plateaus and even continents over millions of years. These can occur through continental collision, volcanic activity or the upward push of heated mantle material, the isostasy. Then it is the subsidence, the sinking or downward movement of crustal sections creating basins, rift valleys and areas destined to become ocean floors. This can result from crustal stretching, cooling and densification or the weight of overlying material like ice sheets or sediment. What is the result? Internal processes are responsible for creating the planet's major topographic features and relief landscape. Now, let's talk about the external geological processes. The first one is denudation. Let's understand about denudation, the origin. These processes act upon the Earth's existing surface powered primarily by solar energy, driving weather, climate and the water cycle and gravity. What's the mechanism? External processes involve the continuous wearing down with weathering, erosion and rebuilding through deposition of the Earth's surface. The next procedure, erosion. This is the removal and transport of weathered rock fragments and soil by natural agents like flowing water, rivers, rain, waves, wind, moving ice, the glaciers and gravity, mass vesting like landslides. Erosion carves valleys, cliffs and coastlines. Let's talk about deposition. This is the settling or dropping of eroded materials when the transporting agent loses energy. For example, rivers deposit silt to form floodplains and deltas. Wind builds sand dunes and glaciers leave behind moraines and outwash plains. Deposition fills in basins and builds new landforms. Now, what are the different agents which support in the processes? Water in all its form, liquid, ice, vapor, is the most significant external agent globally, followed by wind and glacial ice. Each agent leaves distinct erosional and depositional signatures. Now, what are the results of these processes? The external processes relentlessly work to reduce the relief created by internal forces, smoothing, sculpting and redistributing the material. These two sets of processes exist in constant dynamic interplay. Internal forces built up by the land creating potential energy through elevation, while external forces driven by gravity and climate work to level it down, transporting material to lower elevations. This ongoing cycle shapes the incredible variety of landforms we see. Now let's move on to one of the major types, mountains. Earth's magoric uplift. Mountains represent some of the most dramatic and visually striking landforms formed primarily through the powerful forces of internal processes, particularly tectonic uplift. Now let's try and define mountains. It is a significant earth elevation of crust rising conspicuously above its surroundings. Characteristically, mountains possess a relatively narrow summit, the peak, compared to a broad base, giving them a steep-sided profile. Their scale is immense. Many individual mountains and ranges soar thousands of meters. What are the environmental conditions required? Ascending a mountain leads to profound environmental changes. Temperature decreases systematically with altitude, which is the lapse rate, creating cooler, often harsh climates even in equatorial regions. Precipitation patterns change, frequently leading to abundant snowfall at higher elevations. This cold environment allows for the formation and persistence of glaciers, massive, slow-moving rivers of ice that carve distinctive landscapes and persist year-round. Now let's talk about mountains and the human interaction. Mountainous terrain presents significant challenges for human habitation and agriculture. The combination of steep slopes, thin and often rocky soils, harsh and variable weather, including strong winds, avalanches and rapid temperature drops, and logistical difficulties limits permanent settlement and large-scale farming. Mountain ranges. Mountains rarely exist in isolation. Tectonic forces typically uplift vast regions, creating mountain ranges, extensive linear chains or groups of mountains connected by high ground. These ranges often mark the boundaries of tectonic plates. Let's talk about the Himalayan mountains, the planet's biggest range created by the ongoing interaction between the Indian and Eurasian tectonic plates. It contains Mount Everest, the world's highest peak. Next, the mountain ranges example would be the Alps, which is in Europe. A complex interaction of ranges of African plate, Eurasian plates significantly shaped by glacial erosion. A major feature of Central Europe, Andes in South America. The world's long continental hill range running along the edge of Western South America. The subduction of the Nazca plate underneath the South American plate created this landform featuring active volcanoes and high plateaus. Mountains come in different shapes and heights. There are three main types based on how they form. Mountains arise through distinct geological processes resulting in characteristic forms and features. The three principal types are fold mountains, firstly, sculpted by crustal compression. Formation process. These majestic ranges form primarily at convergent plate boundaries where tectonic plates collide with immense force. Under this extreme horizontal compression, the relatively ductile layers of Earth's crust and often underlying sedimentary rocks buckle and deform plastically. Instead of fracturing, they bend into large wave-like structures known as folds. Common fold types include upward arching anticlines and downward troughing synclines. Age and appearance of the fold mountains. The age of fold mountains dramatically influences their appearance. Let's talk about the young fold mountains now. Geologically recent, they are characterized by extremely high, jagged peaks, steep slopes, and deep narrow valleys. Their youth means erosion has not yet significantly worn them down. The examples, the common ones, are the Himalayas, which are in Asia, which are in India, which are formed by colliding of Indian plate with the Eurasian plate. Next is Alps, which are in Europe, which are formed by the African plate colliding with the Eurasian one. Let's now talk about the old fold mountains, formed hundreds of millions of years ago, often during the Paleozoic era. Over vast geological time, the relentless forces of erosion, wind, water, ice, have worn down their peaks, resulting in significantly lower elevations, rounded summits, gentler slopes and broader valleys. And one of the most famous example is the Aravalli range, which is in India, which is among Earth's oldest fold mountains. And then we have the Appalachian mountains, which are located in the eastern North America. And then we have the Ural mountains, which are in Russia, which mark the significant boundary between Europe and Asia. Now let's talk about the next type of mountains, the block mountains, fault block mountains. These are uplifted and down-dropped fragments. Let's understand the formation. These mountains originate from tensional forces within the Earth's crust which pull apart. This stretching causes the brittle crust to fracture along planes of weakness called faults. Large coherent blocks of crust are then displaced vertically relative to each other. Movement along these faults can be extensive. Let's understand the key structures of the fault mountains. Horse. Blocks of crust that are uplifted, tilted or raised between parallel faults. These elevated blocks become the mountains themselves. The next important structure is the garben. These are blocks of crust that sink downward between parallel faults relative to the surrounding horse. These down-drop blocks form valleys or basins. Now let's understand the characteristics of the fault mountains. Block mountains typically have steep, rugged slopes defined by the fault lines, fault scarps and relatively flat tops. They often form parallel ranges separated by linear valleys. For example, the Rhine Valley, which is a garben feature in Europe, flanked by the uplifted Vosges Mountains, which is the host part in France to the west, and the Black Forest, which is the host structure in Germany to the east. And this is a classic example of this host garben system. Now let's understand the third type of the mountain ranges, which are the volcanic mountains. These are built by magmatic eruptions. Let's understand the formation. These mountains are constructed directly from the products of volcanic activity. Molten rock or magma originating from the mantle or melted crust rises towards the surface through vents or fissures. Upon eruption, as lava, ash, cinders, rock fragments, this material accumulates around the vent layer upon layer, gradually building a mountain. Now let's understand the variety of forms. Their shape depends heavily on the type of eruption and the magma's composition. Now let's understand few types. The shield volcanoes, formed by frequent eruptions of low viscosity, fluid basaltic lava that spreads widely, creating broad, gently sloping domes. For example, the Mauna Loa in Hawaii is a great example. Stratovolcanoes, these are also called the composite cones, and these are built by alternating eruptions of viscous lava flows, ash, cinder and pyroclastic material. This results in tall, steep-sided conical mountains, and the example could be Mount Fuji of Japan, Mount Kilimanjaro of Africa. Let's understand the next type, cinder cones. Smaller, steep-sided hills which are formed primarily from accumulated pyroclastic fragments from eruptions. The next type of the volcanic mountain would be lava domes. Lava domes are volcanic mounds created as highly viscous lava slows emerges and accumulates around its eruption vent. Now let's understand the various characteristics of volcanic mountains. Volcanic mountains often have distinct summit craters or calders. They can form individually or in clusters along plate boundaries. For example, the subduction zones, rift valleys, or over mantle hotspots. For example, the Mount Kilimanjaro, which is Africa's highest peak, and it's a dormant stratovolcano. Then we have Mount Fuji, which is Japan's iconic stratovolcano. Now let's try and understand why the mountains matter. Mountains store fresh water in their glaciers and feed many rivers. People build reservoirs in the mountain valleys to capture this water for drinking, farming, and electricity. Mountainous regions provide vital resources. Their waters support irrigation and hydroelectric power generation, while river valleys and terraces offer excellent farmland. These areas boast rich biodiversity and their forests supply essential products like fuel, fodder, shelter, gum, and raisins.